Alright, so what is function notation? Well, I'm sure you've seen the equation of a parabola before. Alright, so that's just the equation of a parabola. But function notation allows us to name it something different. For instance, perhaps we have the line as well. 3 over 2x minus 2. And let's say we wanted to name these functions so that we can tell them apart. We might call one of them f of x, which is the commonly used function, because function starts with f, and we'll call this one g of x. Okay, usually when we use variables, we call them x, y, z. When we use values that stand for constants, we normally use a, b, c, and when we use functions, we use f, g, h, i, j, and so on. Alright, sometimes we use c, r, p comes up a lot, c for cost, p for I forget what P stands for. P for profits, R for revenue. Those come up a lot. But usually use F and G. So, what does f of x mean that g of x doesn't mean? Well, f of x means the value of y when x is something, and g of x means the value of y when x is something, but for the functions that they relate to. So for instance, if we wanted to know what f of 3 would be, we would plug 3 into our parabola. So that would be 3 squared plus 2 times 3 plus 1. So f of 3 would be equal to 9 plus 6 plus 1. That's 16. Okay. If we wanted to know what g of if we wanted to know what g of 7 was, that would be 3 over 2 times 7 minus 2. So g of 7 would be equal to 21 over 2, which is 10.5, minus 2, or 8.5. Okay? Alright, something else that we get asked to do every once in a while is to evaluate a function for something other than a number, which is also possible. Perhaps we'll be asked to evaluate f of x plus 2. That's the same thing as it was before. I'm going to do that over here when I have a little more room. So that would be equal to x plus 2 squared plus 2 times x plus 2 plus 1. Alright, so we're asking what's the value of y when x is 2 greater than it normally is. So that would be, that's x squared plus 4x plus 4 plus 2x plus 4 plus 1. So f of x plus 2 would be equal to x squared plus 6x plus 9. Alright, so you can evaluate with even expressions like that as well. Alright, so let's do one for g also. So let's say we did g of 3x. That would be 3 over 2 times 3x minus 2. So that would be 9x over 2 minus 2. So evaluating functions is not very difficult to do. Alright, you can even use a graphing calculator to do them. For instance, let's take a look at our two functions again. Let me go get my graphing calculator. This is my TI-84. Okay, turn that on. Turn on. Alright. I have a function in there from a previous video. Let's plug in f of x here. I think you can actually put a calculator into function mode, which I don't know if that's useful or not, but let's take a look. Mode has sequential mode. Oh, it has function mode. We're in function mode. There's parametric mode, and polar coordinates, and sequences, and other modes, but we're in function notation. Alright, so y is the same thing as f of x, so let's just plug in x squared plus 2x plus 1. And if we press second graph, we can calculate the value of f of x when x is equal to negative 5. If x is equal to negative 5, f of x is equal to 16. If f of x is equal to negative 4, if x is equal to negative 4, f of x is equal to 9. Alright, so y is just, again, another fancy word. F of x is just another fancy way of saying y. Okay? And I just want to mention one last thing, because it has come up on the trigonometry regions recently. You might be asked to write something in function notation that's not in function notation. Perhaps you were given this function. Y minus 3 equals, I don't know, x squared plus 3. To write this in function notation, you want it to say f of x. And don't forget that f of x is y. So we're going to isolate y by adding 3 to both sides. We get y is equal to x squared plus 6, which means f of x is x squared plus 6. Not that it's really any different than saying y is equal to x squared plus 6, but now it's in function notation.